Okay, so you know that Saturn is 2 million kilometers away, and you want to get there in 9 hours. So to calculate velocity, you just get that velocity in order to achieve such a feat needs to be 61.728 kilometers per second in order to reach Saturn, which is 2 million kilometers away, in 9 hours. You have to get there at a velocity of 61.728 kilometers per second. So that's our V final. That's the velocity you want to get to. 61.728. And we're given that Saturn is 30 degrees west of north. So write that down, west of north. And we're given that VI is 17 kilometers per second, and it's 10, so I wrote right here, 30 degrees, and it's 10 degrees west of north. Okay, so we can draw our a final first, which is 30 degrees, and then you can just draw our VI from the point of origin, like so, which is going to turn out to be 10 degrees. So you want to know what magnitude and angle this and velocity will be in order for the satellite to slingshot and head towards Saturn. So let's think about it. First, we know that here is 17, here's 61.728. So first we draw like a 90-degree angle from here to here. So we know the distance from this line to the vertical line north is 30. Then we know that this line is 60 degrees. We can then calculate that this line, draw this down, then this has to be 30 degrees because there's 60, 30, 90, they add up to 100. So after finding that, we want to find angle for this, the one opposing this. So this is going to be our R. We want to get this angle. So we can use the cosine law in order to solve for this, which is R squared equals A squared plus B squared minus 2AB cosine angle opposite to R. So if we solve for that, plug in the numbers, we don't know R, we want to solve for that. A, let's make it 61.728 squared plus 17 squared minus 2, 61.728, 17 cosine angle here. We can solve for it by subtracting 10 from 30. So we know that the distance from the vertical line to this line is 30, and distance from this line, from the vertical line to this line, is 10. So 30 degrees minus 10 degrees, it's just 20 degrees. Plug that in. We'll get that R magnitude is 46.121 kilometers per second. So all we have left now is to solve for the angle. So we can do that in two different ways. Just finish the box here. Okay. You can draw this, you can finish the line and solve for this angle. Even though the line terminates here, you can just finish it and finish the line until the vertical, for the vertical line, in order to find this angle, which will give us our direction. So we'll solve for this one, let's solve for this angle and this angle. You can do this by solving for this angle first. You know that this angle is 20 degrees, and this magnitude is 46.121. So using sine law, we know that sine of A over A equals sine B over B. Plugging in our numbers, sine 20 over 46.121 equals sine B. We want to solve for B. We want this angle, so we get this magnitude, so 17. B works out to be, just get my calculator, sine 20 divided by 46.121 equals times 17. Then shift solve all of that. We get that B equals 7.242 degrees. So this is this angle. This is 7. Oh, bless me, thank me. 7.242 degrees. So we know that this angle is 30, this is 7.242 degrees, so what's left is this angle. So we do 90 degrees minus 30 degrees minus 7.242 degrees, which is 90 minus 30, which is 52.758 degrees. So this is this angle. Okay, so you want to find this one. So just same thing. So 180, which is a right triangle, always 180 degrees, or any triangle is 180 degrees. So just 180 minus 90, which is this angle, minus 52.758, which is this angle. And after that, we'll get this angle by subtracting. So equals, get that angle is 37.242 degrees. We know from seeing it, it's east of north, so we can write it down E of N. Therefore, the NASA needs to find angle or magnitude that is 446.121 kilometers per second at a heading of 37.242 degrees east of north. In the second question, we're told that rather than Saturn being 2 million kilometers away, it's 1,500,000 kilometers away. So we know that, logically speaking, that the magnitude from the first question, rather than it being 61.278, it's going to decrease because the numerator decreased. So if solving for this, just get 1.009 times 60 minutes times 60 seconds. Get that it equals 46.3 kilometers per second. So logically speaking, if this angle is the 61 and this one is 40, farther, is the 46.3. And let's say 17 has to be constant. So this is 17. It's always constant. So we know that this line is going to be longer than this line, because the value of 17 is constant and the final velocity is constant, it changes. So VF, this is VF1 minus 17, which is our VI in both scenarios. Let's write VI first, is going to be larger than VF2 minus VI, because VF, and here it's larger, it's 61, and here it's 46. Doing the math, you'll find out that this angle is in fact smaller, and the angle, this magnitude is in fact smaller, and the angle itself may change, because here, when it stops, the angle opens up or takes a sharper, more open. The angle here decreases, while here the angle increases. So the magnitude and the direction has to compensate for the lower VF magnitude. And yeah.